Hello students, welcome to AIMS India online classes. This is a chemistry session. Here we are discussing about the chapter atoms and molecules. In this session we are going to say about different types of chemical reactions. First of all, according to law of conservation of mass, in a chemical reaction atoms are neither be created nor be destroyed, isn't it? This we have studied in the earlier sessions in the concept of law of conservation of mass. What we have learned there, in a chemical reaction atoms will be rearranged to form new compounds, but atoms are neither created nor be destroyed. These atoms are the smallest particles which are participating in the chemical reactions. So these atoms will be rearranged. Initially they will be in certain compound form. When they undergo chemical reaction, these compounds they rearrange their atoms so that the new compounds will be formed. So in a chemical reaction, it is a process that is usually characterized by a chemical change in which the starting materials are different from the products. Yes, what happens in a chemical reaction? The reactants taken, that means the starting chemicals taken, will be modified into new substances which we call as products. So how it is happening? The atoms present in the compounds, they are being rearranged. So they undergo recombinations and breakage of bonds and formation of new bonds, so that they form certain new compounds which we call as products. But no atom is being broken in the chemical reaction, and even no atom is being formed in the chemical reaction. That is called law of conservation of mass. According to that, in a chemical reaction atoms are being neither be created nor be destroyed, just being rearranged. So a chemical reaction occurs with the formation and breaking of chemical bonds. So what are chemical bonds? That we are going to learn in our higher classes. No worry. But just simply the chemical bond means the attraction between the atoms in a compound. So that because of that attraction, atoms will be combined together so that they form compounds. So in a chemical reaction, what happens? These attractions or chemical bonds will be broken and some new bonds will be formed, so that new compounds are being formed which we call as products. So based upon these rearrangements of atoms in the chemical reactions are classified into different types. So some common reaction types which we are going to discuss now. Okay, the types of chemical reactions are, one among them is combination reactions, decomposition reactions, displacement reactions, double displacement reactions, and even oxidation reduction reactions. So based upon the rearrangements of atoms, breaking of bonds, and reformation of bonds, the chemical reactions can be classified into these many types. Now let us see these different types of chemical reactions one by one. First among them is combination reaction. The chemical reactions in which two or more substances combine to form a single substance are called as chemical combination reactions. So the chemical reactions in which two or more substances they combine together to form a single product or a single substance are called as chemical combination reactions. See here example they have given, suppose A is a chemical substance and B is also one of the chemical substances. When these two combine in a chemical reaction, if they form a new product which is a single substance AB, then that reaction is said to be chemical combination reaction. Initially there are two substances, individual substances are there. Finally they formed a single substance as product. Such chemical reactions are said to be combination reactions. In a combination reaction, two or more elements can combine to form a compound. Yes, here we shown A and B. These A and B might be two elements. So in a combination reaction, two or more elements may combine together to form a compound, or two or more compounds may combine together to form a compound, or sometimes an element and a compound can combine to form a new compound. So in these different ways, combination reactions may occur. One among them is, in certain combination reactions, two or more elements may be combining together to form a new compound. In certain combination reactions, two or more compounds they may combine together to form a compound. In certain chemical reactions, a compound and an element may combine together to form a new compound. There are different types of combination reactions we can say. For example, for this first one what we told here, if two or more elements they can combine together to form a new product. What we can say example for this? For example, hydrogen and oxygen they combine together to form water. What is happening in that? Hydrogen and oxygen, two elements, they are combining together to form water. So it is a combination reaction in which two elements combine together to form a new compound. And for the second type, what we told here, two or more compounds can combine to form a new compound. Can we say an example for this? Yes, we can. If you say calcium oxide combines with water to form calcium hydroxide, in that calcium oxide is a compound and water is also a compound. And when these two combine, they are forming a single product called calcium hydroxide, lime water we call generally. Anyhow, here calcium hydroxide slaky lime is being formed. In this formation of slaky lime, two compounds they combine. So two compounds can combine to form a new compound. And third one, if you see third type of combination, what is they have given here, an element and a compound can combine. Yes, for this also you can say an example. If you see carbon monoxide on combustion, on reaction with oxygen, forms carbon dioxide. We know here carbon monoxide is a compound and oxygen is an element. Carbon monoxide combines with oxygen to form a new compound called carbon dioxide. So in this way, combination reactions may occur among the elements or compounds, or in between elements and compounds combination also. Okay, let us see some examples here. So when a piece of magnesium is burnt, it forms magnesium oxide. So here magnesium, oxygen both are elements, and the formed compound magnesium oxide is a compound. Now this is an example for the combination of two elements to form a new compound. So how it will be done here, the reaction between magnesium and oxygen? First we have to take a small piece of magnesium ribbon and we have to first rub that with the sandpaper, because there might be some impurities on the surface of magnesium. To remove them, we have to rub that with sandpaper, and then we have to hold this magnesium ribbon with a pair of tongs. Then we have to burn this magnesium ribbon on the spirit lamp or burner. Then this magnesium burns in the presence of oxygen and with dazzling white, and forms a white powder. This white powder is magnesium oxide. Okay, this is a reaction equation which occurs there. Magnesium burns in the presence of oxygen to form magnesium oxide. So here magnesium element reacting with oxygen element and forming a new compound. This we can say combination reaction between two elements. So in this reaction, magnesium and oxygen combine to form a new substance, magnesium oxide. A reaction in which a single product is formed from two or more reactants is known as chemical combination reaction. So we can say this reaction as now chemical combination reaction, because two or more substances combined here to form a new product, isn't it? Two elements they combined here to form a new product, magnesium oxide. So I can say this as chemical combination reaction. We'll also notice the release of enormous amount of heat energy when magnesium is burnt in air. Yes, not only magnesium oxide as product, along with that enormous amount of energy is also produced when magnesium bond in oxygen. That we told, when magnesium bond in the presence of oxygen, it burns with a dazzling white flame. So a flame is produced when it is burning. Then it forms magnesium oxide. So heat energy is produced out in this reaction. So let us discuss here some more examples for the combination reactions. Burning of coal. We know when coal is burnt, it produces carbon dioxide as product. So what is happening here? Coal, nothing but carbon. Carbon is burning in the presence of oxygen, forming carbon dioxide. Here what is that? An element carbon is combining with another element oxygen to form carbon dioxide. Two substances combined here to form a single product. So it is a combination reaction. You can observe here in this reaction also heat energy is evolved. One more example. Slaked lime is prepared by adding water to quicklime. Here quicklime means calcium oxide. So calcium oxide, if it is added with water, it forms a calcium hydroxide, which is called as lime water, or calcium hydroxide is also called lime water or slaked lime. So this is a equation related to that. So when calcium oxide combines with water, it forms calcium hydroxide as product. What is happening in this? If you observe, a compound calcium oxide combining with another compound water to form a new compound calcium hydroxide. So in this, two compounds combined together to form a new compound. Now we can say this also as a combination reaction. If you observe here, in this reaction also heat energy will be evolved. Okay. So a large amount of heat energy is released in this reaction also when calcium oxide reacts with water. In the formation of calcium hydroxide, enormous amount of energy will be produced in the form of heat here also. So if we touch the container in which we done this reaction, we feel that hotness. So what we can observe from that, as it is being hot, heat energy is evolved. So in this kind of reactions in which heat energy is evolved along with the products, those reactions are said to be exothermic reactions. The chemical reactions in which heat energy is evolved in the formation of products are called exothermic reactions. Okay, so here the formation of slaked lime from calcium oxide and water is an exothermic reaction because heat energy is evolved. So a solution of slaked lime produced in this reaction is used as whitewash for the walls, isn't it? This slaked lime or calcium hydroxide formed is used as whitewash for the walls. So this contains calcium hydroxide. This calcium hydroxide reacts slowly with the carbon dioxide in the air and forms a thin layer of calcium carbonate. So this forms like a thin layer. It gives a white shiny finish to the walls. So that the calcium hydroxide applied onto the walls slowly reacts with the atmospheric carbon dioxide and finally forms calcium carbonate. This calcium carbonate layer gives a shiny finishing to the white finishing to the walls. Okay, anyhow, it is an exothermic reaction as heat energy is evolved. Next type of reactions, chemical decomposition reactions. The reactions in which a compound splits into two or more simpler substances are known as chemical decomposition reactions. So what is happening in these reactions? Quite opposite to combination reactions. We told in the combination reactions, two or more substances combine together to form a single product. That is called combination reaction. But reverse to that, that means a single substance splits into two or more simpler substances is called chemical decomposition reaction. If you see here, a compound AB is taken. After the reaction, it is splitting into two separate substances A and B. Now, This reaction is said to be chemical decomposition reaction. The decomposition reactions carried out by applying heat, light, and even electricity also. So here, for the decomposition of a compound into two or more simpler substances, here we need sometimes heat energy, sometimes light energy we use, and for sometimes we use electrical energy also for the decomposition of substances. So now let us see here some examples for these decomposition reactions here. Take a pinch of calcium carbonate. Yes, if you heat this calcium carbonate, that splits into calcium oxide and carbon dioxide. So a compound calcium carbonate, or which we also call as limestone. This on heating decomposes to form calcium oxide and water. Water. Two new compounds will be formed. Calcium oxide and carbon dioxide. Sorry. So two compounds are formed from a single substance. This reaction is said to be chemical decomposition reaction. This occurs in presence of heat energy by giving heat energy. So how it is done? See here experimentally. We'll take a pinch of calcium carbonate in a boiling tube or test tube. We fix that test tube to test tube stand, and a rubber cork is connected to that with the delivery tube. Now when this calcium carbonate present in this test, test tube or boiling tube, if it is heated by using a Bunsen burner or spirit lamp, this calcium carbonate decomposes to form calcium oxide and carbon dioxide. So this calcium oxide powder will be remained inside, and the carbon dioxide gas will come through this delivery tube out. So we can test this gas coming out. If you bring a burning matchstick or burning splinter near the open end of this delivery tube, immediately we can notice that matchstick will be put off, because carbon dioxide is a non-supporter of combustion. Immediately the burning splinter or matchstick will be put off, as carbon dioxide coming from the delivery tube out. So in the above activity, on heating calcium carbonate, it decomposes to form calcium oxide and carbon dioxide. So this is the equation related to that. Calcium oxide on heating, it is splitting into two compounds, calcium oxide and carbon dioxide. So it is a thermal decomposition reaction. What does it mean here, thermal? The chemical reaction which is occurring with the help of heat energy are called as thermal reactions. So here the decomposition of calcium carbonate is carried out by the heat energy. So it is called as, this decomposition reaction is called as now thermal decomposition reaction, because heat energy is utilized in this reaction. So it is a thermal decomposition reaction. Okay, now let us see one more example. Heating of lead nitrate. If lead nitrate is heated, then it produces lead oxide. Okay, lead oxide, oxygen, and nitrogen dioxide. Three products will be formed. So when a substance, if it is heated, it is producing three new compounds. New substances are being formed. So it is a decomposition reaction. Here also, this lead nitrate on heating, it is giving products. So this is also thermal decomposition reaction only. Now let us see what the process they have followed. First, a small quantity around 0.5 grams of lead nitrate is taken in a test tube, and it is held with the test tube holder. Now if it is heated on a Bunsen burner or spirit lamp, this lead nitrate slowly decomposes to form lead oxide, oxygen, and nitrogen dioxide gases. Okay, so it is a decomposition reaction. So we observe that brown fumes liberating in the boiling tube. Yes, we told here this lead nitrate on decomposition producing lead oxide, solid substance, oxygen and nitrogen dioxide gaseous substances. Out of these two, this nitrogen dioxide is a reddish brown colored gas. So we can see on heating slowly the evolution of reddish brown fumes coming out from the test tube. From that we can understand this lead nitrate is decomposed to form these products. What are those? Lead oxide, oxygen and nitrogen dioxide. Of course, for the oxygen there is no color, but this nitrogen dioxide is brown colored gas. We can observe the fumes of brown colored nitrogen dioxide gas coming out from the test tube. By that we can understand decomposition reaction occurred. These are equation related to that. Lead nitrate on heating giving lead oxide, nitrogen dioxide and oxygen. Okay, this also will come under thermal decomposition reaction only because it is also occurring with the help of heat energy. And some decomposition reactions carried out by using electricity. Yes, not only with the heat, some chemical reactions occur, some decomposition reactions occur with the help of even electricity also. Let us say an example for that. When electric current is passed through acidified water, it decomposes to give hydrogen and oxygen gases. Yes, when water is undergone electricity, that means actually we know pure water is a poor conductor of electricity. So to make it good conductor of electricity, certain amount of acid is added into that water. Few drops of acid is added. Then that acid added water, which is simply called as acidified water. Acidified water means water added with few drops of acid. So by the presence of this acid, this water can conduct electricity now. Now, when electric current is passed through this acidified water, the water decomposes to form hydrogen gas and oxygen gases. So this is the equation related to this. Water, when electricity is applied, decomposes to form hydrogen gas and oxygen gases. So what's happening here? A compound splitting into two new elements in the presence of electricity. Now we can say this is decomposition reaction. So this is the equipment generally used for electrolysis or decomposition of water in the presence of electricity. They use two electrodes which are connected to a battery and they are covered with two test tubes, inverted test tubes. When water is decomposed at these electrodes, the gases produced will be collected into this inverted test tubes. See here, in one test tube oxygen is collected, in another test tube hydrogen is collected. So we can understand here water is decomposing to form hydrogen and oxygen gases. This is occurring in the presence of electricity. This decomposition reaction, which is taking place in the presence of electricity, is called electrolysis or electrolytic decomposition reaction. Okay, the decomposition reaction which is occurring in the presence of electricity is called electrolytic decomposition reaction or simply called electrolysis. So it is electrolysis of water. Electro means electricity. Lysis means a splitting. So the splitting of water into hydrogen and oxygen is occurring in the presence of electricity. This is called electrolysis of water. Electrolysis we call simply, not but electrolytic decomposition of water. Okay. So this is a decomposition reaction which is occurring in the presence of electricity. Some decomposition reactions carried out by light energy also. Yes. For example, if silver bromide taken in a watch glass kept in sunlight for some time, silver bromide decomposes to give silver and bromine in the presence of sunlight. So light yellow colored silver bromide turns into gray due to this sunlight. So what is happening? If a silver bromide is kept in the sunlight for certain time, this silver bromide in the presence of sunlight decomposes to form silver and bromine gases. So bromine gas will be escaped out. It remains there gray colored silver powder. Okay, here what is happening? Silver bromide compound splitting into silver and bromine elements in the presence of sunlight. So it is a decomposition reaction. See here the reaction related to this equation. Silver bromide in the presence of sunlight giving silver and bromine. Okay. So initially silver bromide is a light yellow colored substance. So when it is exposed to sunlight for certain time, it forms a gray colored silver and the bromine gas will be escaped out. So it remains there, gray colored silver metal. This decomposition reaction occurs in the presence of sunlight, and such chemical reactions which are occurring in the presence of sunlight are called photochemical reactions. So it is the decomposition of silver bromide into silver and bromine is a photochemical decomposition reaction, we can say, because it is occurring in the presence of light energy and it is a decomposition reaction. So altogether you can say it is a photochemical decomposition reaction. Photo, nothing but light. Chemical reaction which is occurring in the presence of light is called photochemical reaction. Okay. So all the above decomposition reactions which you have discussed like thermal decomposition reactions, electrochemical decomposition reactions or electrolytic decomposition reactions, and even photochemical reactions. In these all decomposition reactions, we observe one thing common, that is they require energy in the form of either heat, light or electricity for converting the reactants into products, isn't it? Yes. So these all kinds of reactions in which certain form of energy is utilized for the formation of products are called endothermic reactions. Okay. Endothermic reactions. That is about decomposition reactions. So for the decomposition of chemical substances, certain form of energy is utilized. That might be heat energy or electrical energy or light energy. That is why they are called endothermic chemical reactions. Okay. Thank you for watching our video. Please subscribe our YouTube channel AIMS Today and visit our website aimstoday.in for latest updates and recorded videos.